Hello everyone, in this recording we'll discuss graphical queries. The idea of a graphical query is that we can define inputs to an interactive visualization using figures themselves. So it's a little bit of an abstract idea, but think about it this way, right? So instead of having a slider saying, I want all the values between these two endpoints, you could have a histogram showing actual values of a data set. And you could imagine drawing a range over that histogram and using that to select in some other plot. Similarly, if you had a long drop-down menu of a bunch of different options, you could imagine replacing that drop-down menu with a bar plot, where each bar corresponds to one of the options, and clicking on the bars can be used to select items. So whenever you can use graphical queries, you should. The reason is it increases the amount of information that's encoded in the visualization. The selectors are not just kind of tertiary elements, they're actually ways of encoding information. Let's look at an example of this, starting with click events. How do you define a click event in Shiny? We've already seen plot output before. It's the way that we were embedding plots in our apps. If you give plot output this argument called click, then it's going to create an event where every time you click on that plot, we're going to be able to notice it in the server. Here I've just given that click a label called plot click. You could give it any label that you want. Okay, so in order to use information that the user has clicked, we need two things. We need to first know that a click has happened, and then we need to figure out any important information about that click, right? So maybe if the user has clicked on a certain point, we need to know that that user has clicked on that point. So how do we do each of these tasks? First, to notice whether a click has happened, we can use these observe events. The way it works is whatever you gave us the argument for the plot output, click, use that as the first argument in observe event, and then whenever that particular plot is clicked, any code within this observe event is going to be rerun. It's a little bit different from reactivity, right? It's having to keep track of these inputs. So how do we extract relevant information? Shiny comes with a very handy function called nearpoints. And what it can be used to do is it can be used to find, if you just use this, it's going to find the closest sample to the wherever you clicked. And often useful thing to do is return all the samples along with their distances to wherever the user has clicked. So it's doing all this calculation in the background, figuring out the distance from all the plotted points to where the user has clicked. Okay. So let's illustrate this using a kind of toy example. The idea of the plot is going to be, let's make a scatter plot where wherever the user has clicked, the points that are close by are going to be large, and those that are further away will shrink them. Right, so somehow we need to keep track of all these distances, and we need to update the plot every time the user has clicked. So this is the entire code for it, in at least the server code. I've hidden away the ggplot scatterplot into the scatter function. There's one very new idea here. This very new idea is this reactive value variable. You can think of it as something in between a variable and a kind of a function, or like a reactive node in the reactive graph. You can think of it like a variable because it is just this vector, and we are initializing it with a vector of all ones for every row in this scatter plot, or every point in the scatter plot. But it's a variable that we are going to be able to update in the observe event. So what is happening here? Every time the user has clicked, we're going to change the distances. So I've hidden away also a function that's storing all these, is getting all the distances based on this plot quick. And then it's going to replace the all ones with, it's now going to have very small numbers for the rows which are close to where the user has clicked, and very large numbers for where the user, points that are very far from where the user has clicked. By using this kind of function kind of syntax, what it's doing is it's resetting the value of this reactive value. We think of it as assignment, but it's a specific form of assignment for reactive values. Now, the really critical thing about a reactive value is that every time its value changes, any downstream node is going to be rerun. So what are the downstream nodes in this case? Notice that dist also appears here. It appears in this render plot. So there is this plot output, which depends on this reactive value. So that plot output is going to be updated every time this reactive value changes. In this case, it's just going to change the size of the points according to the new value in dist. Okay, so this is actually a very general pattern. Whenever you're working with click events, we'll see it again in brush events. You will often have server code where at the very beginning you initialize some reactive value, some variable storing information. It could be which points are currently selected, it could be which points are currently close by. You're going to observe any user interactions on a plot. So maybe they're clicking on points, maybe they're dragging a brush over some points. Based on all that input, you're going to update this reactive value. And when that reactive value gets changed, it will force a rerun of whatever the render plot is. Okay. So that's a little bit abstract, but that is going to be a very common pattern. Okay, so let's look at the full working example. Maybe let's look at what the app does first, and then we'll look at it. So imagine this is all it's doing. It's when I click near some point, it's going to get larger, and then the ones that are further away. So how did this work? Okay. There are these two functions which I defined in advance. This reset dist is really just a little wrapper function of near points, which I mentioned before. The only thing different is it just extracts this distance column so that we don't have to do any further processing. We can just plug that right into our reactive value. Scatter is just an ordinary scatter plot where I'm encoding the size of the points, or the size of the points is encoding the distance. Okay. And then from there, the server is exactly like what we have seen before. We initialize with all ones. Every time the user clicks, we're extracting the new distances using near points, getting those new distances, substituting it into the reactive value. Once the reactive value changes, that forces an update on render plot because we call the reactive value here. Okay, let's make the plot a little bit more interesting. Instead of just having a scatter plot, let's also have a table. So now you'll be able to see which cars are the ones that the user is clicking near. The way you get this here, it's almost exactly the same as what we've been doing before. I've added a data table output. Here's a render data table. I'm just showing the original data set. I've added a distance column, which is showing the distance from where the user has clicked. Again, it uses the exact same intermediate reactive value node, and it's just sorting the table that comes out. So the ones with very high miles per gallon low horsepower, these cars. The ones with very high horsepower, low miles per gallon, are these cars.